Hello, Lovelace, and welcome to today's science lesson. Now, it's the last science lesson in this unit. Remember, we've been looking at materials and their properties, all the different qualities that different materials have that make them useful or not useful for different jobs. We've looked at things like how transparent they are, how opaque they are, so whether light travels through them. We've looked at absorbency to see how much liquid they can store or hold. We've looked at water resistance to see if they're any use at keeping water off the contents and various other things. We've talked about strength. We've talked about flexibility. We've talked about lots and lots of different properties. But the materials today are a little bit special because their properties actually change. So here's our question for today. Can I investigate the difference between Newtonian and non-Newtonian liquids? Now, they are quite complex phrases, so don't worry. We're going to explain them as we work our way through. Now, I hope that we all know the difference between a solid and a liquid. Yeah, I hope so. Just to clarify, just to define, a solid is a shape that does not change on its own. So it holds the shape it's in. The only way it changes shape is if we apply a force to it. So if we squeeze it or push it or cut into it. So that's the only way that a solid's shape can change, is if we actually apply a force. Okay, so that's a solid. And a liquid it's not rigid, it doesn't hold its shape, it actually takes on the shape of the container we put it into. So if you think, what is the shape of water? Well, it doesn't really have a shape. It's whatever shape the container is. So if we put it into a glass, then the water is the shape of the glass. If we put it into a pan, then it takes on the shape of the pan. Okay, so a solid holds its shape, it's rigid. A liquid doesn't. It takes on the shape of the container we put it into. Okay, so a liquid will flow. Now, as I say, today's experiment, today's material is a little bit strange because there are times when it behaves like a solid and there are times when it behaves like a liquid. But let's take a closer look. Now, first of all, let's look at normal liquids. Now, we call most liquids Newtonian. Now, that's based on the famous scientist called Isaac Newton, who discovered gravity. Okay, so Newtonian liquids behave in a predictable way. They behave in the way we would expect them to behave, based on whatever forces, whatever heat, whatever we're doing to them. So how they behave is expected. So here we've got water pouring out of a tap, and it's got a constant viscosity, another fancy scientific word. But viscosity simply means how easy or how difficult it is to pour. So basically, it's how thick the liquid is. So water is a very thin, runny liquid. So water has got a very low viscosity. Okay? It means it flows really, really easily. But something like syrup, which pours a lot slower, it's quite a bit thicker, that's got a high viscosity. Okay? Now, so then they are Newtonian liquids because they've got a constant viscosity. Okay, they've got a predictable one. We expect something with a high viscosity, something that's thick. We expect it to flow quite slowly. Equally, something that's got a low viscosity, really, really thin, we expect to flow really quickly. Okay, and that's what's happened. What happens with a Newtonian fluid. Okay, and there we've got some golden syrup. Delicious, but if you try and pour it out of the tin, it's quite thick and gloopy and pours quite slowly. So it's got a high viscosity. Now, a non-Newtonian liquid or fluid is a substance that can copy the properties of a solid or a liquid. So it can behave like both. And we sometimes call these substances oblate. Okay, so oblate fluids or non-Newtonian fluids. And they can be a bit of fun. So here's a question for you. Can you walk on water? Well, Obviously, the answer is no. You take your first step, or maybe you get to your second step before you fall into the water. Okay? We can't walk on water. Water is a Newtonian liquid, and therefore it behaves as we'd expect. You try and walk on it, you're going straight through. Can you walk on custard? Now, that's a more interesting question. And depending on the type of custard, the actual answer is yes. You can walk on custard. And at the end of today's lesson, I'm going to invite you to watch a video clip. Now, that clip, the link is in our plan for the week. It's also in the description for this video. And it shows you how you can walk on custard. And there's just a little still from the video to show you how it's done. But during the video, they'll explain exactly how they create the mixture and how you can walk on custard. And today's investigation is along the same lines. Now, I'm not going to invite you to walk on custard, but you're going to create a similar sort of material, similar sort of substance. Okay. Now, excuse me. Now, as we're closing this half term, I thought I'd finish with a little bit of a fun investigation for you. And this is a great one to try at home, but you will need certain ingredients. So don't panic if you've not got them in the house right now. This is one you can put to one side, and the next time you go shopping, maybe pick some of these things up, and then you can have a go at another time. So don't panic if you can't do this today. It's not a problem. It's a nice one just to play around with when you have a bit of time, maybe over the holidays even. So you're going to need corn flour or cornstarch. To be totally honest, corn flour is probably going to be easier to find over here in the UK. Cornstarch tends to be something more popular in America. So corn flour or cornstarch, and there's actually some custard powders out there that contain corn flour, but you need to read the label. Don't just be buying any powdered custard. Make sure it contains corn flour. But as I say, probably the easiest one to get hold of is just corn flour. Okay, there's the Asda's version, Morrison's, Tesco's. So these you'll find in the baking aisle with the flour, with the sugar, with all the other things that are needed for cakes. Okay, so corn flour or cornstarch. Now, for my experiment, I'm using corn flour. It was just the easiest one to get hold of. So that's the reason I chose it. You might need to research your measurements if you use a different ingredient. So if you do decide to use either the custard or the cornstarch, you might just need to do a quick Google search to see what the mixture needs to be. Okay, so the ingredients or the measurements I'm going to give you are for corn flour. Now, warning, this could get messy. This is one to do maybe on a kitchen counter, something that you can wipe down easily, something that's not going to get damaged or get people in the house upset if you make a bit of a mess. You might even want to lay down some newspaper or some sort of sheeting just to protect the surfaces. As you can say, it's a bit of dust and a bit of water. So we're not going to create any major damage, but we might make a bit of a mess. Okay, so well worth thinking about where you do this investigation. You're going to need your corn flour. I used 225 grams. You're going to need some water, 230 milliliters, a mixing bowl. Plastic is probably a better option. You can do it in other materials of bowls, but because of what you're going to do with the mixture, and sort of say it's probably safer to be using a plastic bowl because we don't want anything to get broken. A spoon if you want to, although it's great to get your hands mucky on this one, and a plastic food bag, and that will become clear at the very end why we need that. Okay, now these measurements are for the size of mixture I'm going to make, but for you, obviously you can go bigger if you like, but this is a good start. Right, so what do you need to do? Well, first of all, put your water into a bowl and then very slowly add the corn flour. Now, just as an aside, warm water does tend to mix a little bit better. If you use cold water, the mixture can get a little bit bitty and be quite tricky to mix. So if you just use warm water, Mixture of hot and cold from the tap is fine. So warm water will just mix a little bit better and get smoother a little bit quicker. So the water and the corn flour into a bowl and mix. You stir it together using your hands or a spoon. Stir quite slowly. If you stir quickly, it will actually get thick. It will become very bitty. So stir it thoroughly, but stir it reasonably slowly. Don't put too much force into it. Now, at this point, once you've got a nice mixture, you can add a bit of food coloring if you want to. Okay, but it does make the whole thing a little bit messy, and food colorings can stain your hands. So if you're choosing to use food coloring, you might want to wear plastic gloves or use the spoon. You decide. But I can say it's up to you whether you use it or not. It's just to add color. It's just for an effect. So you might choose not to bother. Now you just keep on mixing that until it's a really, really smooth mix, about the consistency of honey. Okay, so like a really thick liquid. And if you need to add a bit more corn flour or a bit more water to get that nice consistency, then go for it. Okay, but you're trying to create that sort of a thick, smooth liquid, a bit like honey. Once you've got that, it's time to have a play with it. And I've got 3 tasks for you to try. The first one, just push your hands into it, but push them in slowly. Okay, so just gradually put your hands into the mixture. Now, if you're doing that right, if you've got a nice mixture, then it behaves like a liquid and your hands just move through it quite easily. Nothing particularly surprising there. Okay, at the moment, our non-Newtonian fluid is behaving like a liquid. We can just move our hands slowly through them quite easily. But activity number 2, this sounds a bit strange, but I want you to try hitting or punching the mixture quite hard, okay? Because the more force you apply to this mixture, the more it turns into a solid and behaves like a solid. Now, most liquids, if you punch them, if you hit a liquid, it splashes all over the place. But this one will actually turn hard. Okay? It will resist your hand. It will force against it. And this is because under force, the water actually flows away and it just leaves the corn flour particles under your fist. It leaves a solid under your fist. And it's the strangest of things. Okay? Now, you might want to sort of build up your force gradually to help with your confidence. But trust me, if you've made a really nice mix here, then punching, it sounds really, really strange even saying it, but punching the liquid and your fist will actually stop on the surface, okay, as if you are hitting a solid thing. Okay, give it a go. Give it a go. This is one of those where you do want to be sure that you're surrounded by, it's a nice washable surface, or you've put a newspaper down or whatever, because there might be a little bit of splash. There's always a little bit of extra liquid there. But generally, it's going to behave like a solid, and you're going to be really, really surprised at the feeling and the effect of this one. Finally, try scooping it up. Actually, get a scoopful in your hand and roll it into a ball. Because as you apply that force, as you apply that pressure, it will actually turn into, similar to Play-Doh, it will turn into a solid, a soft solid, like plasticine or clay, but it will turn into a solid and start behaving as such. But you have to keep it moving. Okay? You have to keep applying the pressure. You have to keep rolling. Because as soon as you stop applying pressure, as soon as that force disappears, then your mixture is going to turn back into a liquid and pour back into the bowl. So keep your hands over the bowl, because as soon as you stop playing with it, it's heading straight back into a liquid. So be careful with this one. But it really is very, very curious how this mixture can behave like a liquid, and then all of a sudden it becomes a solid just because we're applying a force, just because we're rolling it in our hands. Okay. Now, one thing you can try is adding either more water or more corn flour to your mix to change the consistency. to change how thick it is. Does that affect any of these experiments, these investigations? If you add a lot more water, does it still behave like a solid when you add a force? Or if you apply a lot more corn flour, does it still behave like a liquid when you take the force away? So at what point does it stop being a non-Newtonian fluid? Okay, just a few things to sort of play around with, experiment with, and try out. Okay, so we've tried just slowly moving our hand through it. We've tried hitting it and applying a real force, and we've tried rolling it around in our hands, and then possibly changing the consistency by adding more water or more corn flour. Now, throughout this, it'd be great if you could take some photos of your non-Newtonian fluid and upload them onto Tapestry so I get to see some of the mess that you're making. But when you're finished, and this is really important, guys, do not, and I'm repeating this, do not pour your mixture down the sink. Okay? The corn flour will clog up your drains and it'll make a real mess. So please do not pour it down the sink. Put it into the bag. Remember, at the start, I asked you to have a little plastic bag handy. Put it into the plastic bag, tie the top, and just throw it in the bin. Okay, that is the safest way to dispose of this mixture. So we don't put it down the sink. We put it into a plastic bag or something similar, tie a knot in it, and put it in the bin. We then go back to where we were working and make sure we have tidied up all the mess we made. Okay, right. Now, in the middle of that, I said that there's a short video I'd like you to watch. It's from an old TV show, a science show for children called Brainiac. Now, it's not on the TV anymore, which is a shame. But during that show, they did an experiment to see if you could walk on custard. And if you click on the link within the description, or the link that's on the planning sheet, then you will see a clip just shy of 4 minutes showing exactly how this can be done. Okay, and it's well worth a watch. Really, really interesting to see what happens when they fill a swimming pool with custard. Okay, well worth a watch. But for now, that is the end of today's lesson. Okay, you look after yourselves, guys. So stay tidy, stay safe, and look after those around you. And I will see you all very soon. Take care.